Now you might think to yourself, why the heck are we counting the number of significant figures in a measurement? Well, who cares? All I have to do is write down the measurement. Well, it matters because what do we do with these measurements usually? We do math. And in math class, you just do math and you plug numbers into your calculator, and whatever the calculator spits out, that's the answer, and there you go. But that's because in math, you're not really dealing with measurements. Measurements have uncertainty. Uncertainty carries through your math, and it makes your answer even more uncertain. So we have to take that into account. Now again, it doesn't matter how these rules work. What matters is that you learn the rules and can apply them. And there's only two for using significant figures in calculations. The first rule has to do with addition and subtraction. When you add or subtract any numbers, your answer has to have the same number of decimal places as the measurement with the fewest number of decimal places in the calculation. So you're going to do some addition and subtraction of numbers. You're going to look at each of the numbers that you're adding and subtracting. You're going to see which one has the fewest number of decimal places after the decimal point, and you're going to round your answer to have that number of decimal places. Simple. You don't have to know why you're doing it, you just have to do it. For multiplication and division, it's a little different. In multiplication and division, your answer has to have the same number of significant figures as the measurement that has the least number of significant figures in the calculation. So again, you're doing multiplication or division, you look at each of the measurements that you're multiplying and dividing, you count the number of significant figures in each of those measurements. Whichever one has the least number, that's the number of significant figures that you round your answer to. It'll help if we do a couple of examples. So here we have a piece of copper wire. Our copper wire is 14.5 centimeters long. We're going to cut a piece 7.38 centimeters from that wire. What's left? Well, this is not a difficult math problem. 14.5 minus 7.38 is the answer. And when you plug that into the calculator, you get 7.12 centimeters. But here's the problem. The 5 in 14.5 is uncertain. Somebody estimated that, which means it might not really be a 5. And if it's not really a 5, then that changes the 1 in the 7.12 to something else. So we're only allowed to have one uncertain digit in our measurement. So when I subtract those two, 14.5 minus 7.38, even though the calculator says 7.12, I can't really be certain about that 1. And since I'm only allowed one uncertain digit, I have to drop the 2. Now I drop the 2, and the 2 is not big enough to change the 1 to anything else, so I leave it as 7.1. Well, what's the rule? When subtracting or adding, my answer has to have the least number of decimal places. So look at the two numbers that I subtracted. 14.5 has 1 decimal place, 7.38 has 2 decimal places, 1 decimal place is less, so my answer will have 1 decimal place. And I just round it to 1 decimal place. And I'm right. I don't even have to know why I'm doing it. What about multiplication and division? Here's one, density. We already know how to calculate density. It's mass over volume. So we're going to calculate the density of a piece of lead. The mass of the lead is 25.00 grams. That was measured on a centigram balance. And the volume is 2.21 cubic centimeters. So how do we calculate density? Density is mass divided by volume. So density is 25.00 grams divided by 2.21 cubic centimeters. And if we plug that into our calculator, it spits out 11.31221719 cubic centimeters. That number has way too many decimal places. Even if you didn't know anything about significant figures, you would look at that number and go, I should probably round that. There's too many decimal places. I can't be that certain. Well, think about it. The 25.00 grams, that last 0, that's uncertain. And the 2.21 cubic centimeters, that 1, that's uncertain. It carries a lot of uncertainty. It means our answer can't be that certain. We have to round it. So what do? The rule is, when I'm multiplying or dividing, my answer has to have the same number of total sig figs, significant figures, as the measurement with the smallest number of significant figures in the problem. 25.00, if we count the number of significant figures, has 4. The 2, the 5, and then the 2 zeros are after the decimal point, so they're significant. That's got 4. 2.21 cubic centimeters, that only has 3. So I have to round my answer to have 3 significant figures. I take the first 3 I encounter, 1, 1, and then the 3. And I drop everything else. And I get 11.3 grams per cubic centimeter. That's my answer, with the correct number of significant figures. This takes practice. You will have to get used to counting sig figs, and you'll have to get used to using these two rules. But you'll have plenty of practice. Anytime you do a calculation in this class, you must have your answer have the right number of significant figures according to these rules. We'll practice it. You'll get it right.